Good morning everyone. So today we're continuing with the Boolean Algebra chapter, and in today's video I'm going to discuss about the solve exercise. So this is from the solve exercise question number 92. So the question is obtain a simplified form for the following Boolean expression using K-map. So here this is the function which has four literals. Okay, so that means we will, so since there are four variables, that means the K-map will be a four variable K-map. So as you can see that this is a four variable K-map, and the function equals to sigma. Okay, and these are the minterm designations. So decimal designation, that is based on this decimal designation we have to put the minterm values in the K-map. So sigma, since sigma represents the SOP, that means the minterm SOP, and in minterm the function output is represented by the value 1, and for max term the function output is represented by the value 0. So since in the K-map you have the output value as 1, so that means the reduced Boolean expression will be in terms of minterm SOP form. So here in this diagram, you see that this diagram is just to show you the decimal designation of each cell. So here you have four variables. U and V represents the row, and W and Z represents the column. So the index position will always be in this format. Okay, for the four variable K-map 0 0 0 1 1 1 and 1 0. So which means that based on this index 0 and 0 0 0, the decimal place for 0 is in the first cell, and based on this 0 1 0 0 in binary number system, 0 1 0 0 represents the decimal number 4. So here, and 0 0 0 1 represents decimal number 1. So here in terms of the mean term, alright, since the decimal designation is 1, that means the mean term m1 lies here. So based on that we have to place the these decimal values in this K-map. So here you see that sigma 0 0 is in this position, so we place here the output 1 3. So 3 is here, so the output 1 is placed here. Since 1 represents the mean term, right, for max term it will be 0. 4 is placed here, 5 is placed here, okay, 7 here, 11 here, okay, then 13 and 15. So likewise we fill up all of these decimal designation in the K-map. Now by that you can see that we can further reduce this to the minterm SOP form by using the pair reduction K-map format. So in K-map we can use the pairing reduction of the minterms, that is by joining the adjacent cells which has minterms. Like in this case, this minterm and minterms is adjacent, so we can form a pair. Likewise, this one, this one, this one, and this one, there are four minterms, so we can join together to form a quad. And similarly we can join these four minterms to form a quad. So a quad can be horizontal, can be vertical, can be a square. Now when we have to reduce this expression, then we have to start with the highest pairing order, that is octet, then followed by pair, and then followed by octet, followed by quad, and then pair. So here what we do is that first we reduce the Boolean expression starting with a quad pairing. So we start with this quad pairing or this pair. So here, since the out K-map is filled with 1 as the output, so that means this is a mean term, right? This represents a mean term. So here you see that this mean term 1, in term when we find the function for that, so here u complement v, w complement and z, which means this one. All right, so here this in terms of decimal it is 0, which means that uh, oh sorry, quad. First we start with quad. Okay, so here u is 0 and w is 1, uh, uh, v is 1, w is 0, and z is 1. So in minterm, uh, just remember that the literal which has the value 0 gets complemented. The literal which has the value 1 as the input does not get complemented. So here 0, u and w gets complemented to u complement w complement. So that's why we write here u complement v, w complement z. Similarly, this cell has u complement v, and then w and z has 1 1, so it remains the same. Okay, u complement v, w and z, plus the next quad minterm. So u v and then w is 0, so w complement z. Okay, plus here u and v is 1 and w and z is also 1 for this particular cell, so it remains the same, u v w z. Now in quad we eliminate two literals, that is the literal which changes its from complement to non-complement or non-complement to complement. So here you can see that u changes from 0 to 1. Okay, v remains the same, w changes from 0 to 1, and z remains the same. So u and w is eliminated. Okay, and then we get the output v and z. So here you can see that these four minterms gets reduced to just one minterm because two literals gets eliminated. Similarly, in this quad you can see that u and v remains the same 1 1 for all the cells, but w and z changes from 0 to 1, 0 to 1. Alright, so in the next quad w and z gets eliminated and we get u and v only. Now finally we move on to the pair. So in the pair, u and v remains the same, that is u complement v complement for this cell and this cell also. W also remains the same, u 0 0, z changes from 0 to 1. So z is eliminated because in pair only one literal gets eliminated. Alright, so here you get u complement v complement w complement. Now finally what we do is that to get the reduced SOP minterm form, we OR all these minterms obtained from the two quads and one pair. So after ORing the minterms, we get f equals to vz plus uv plus u complement v complement w complement. Right, so all this expression gets reduced to this SOP form. Now this is one type of orientation. Right, so similarly here you can see that this is the previous one, this is the previous KMF form. Now it can also be in this format. Right, the only thing you will observe is that it looks different, the diagram looks different, but the output will be same because the orientation of the decimal designation has changed here. That is, in terms of the u and v represents in this case column, and v, w and z represents row in this. So you see here 0 4 12 and 8, it is horizontally represented here, but in here it is vertically represented, and 0 1 3 and 2, in this case it is horizontally represented. Right, so you just change the position of that. However, though the diagram looks different, yet the output you will get the same. So you just try this and then you will see that you get the same output, because here you see that u v this is 0 and 4, and in this case this is also 0 and 4. Right, except that here 4 you read it in this format 0 1 0 0, that is 4. Okay, now if you read here in this format 0 0 0 1, that becomes 1, so it should be 0 1 0 0, so that is 4 in terms of decimal. Right, so likewise you get the same output. Now similarly here is another problem. This is from question number 94. Here also you have four variables a, b, c and d, and sigma represents the SOP form. So you have to insert all of these decimal values in the Karnaugh map. So after inserting it based on this orientation, after inserting the function output 1 1 to represent the mean terms. All right, so all of this represents the mean term. So here you see that you can form a quad with these four mean term values, and since this is isolated, then what you can do is that you can overlap with this quad to form a pair. Right, so this one is shared with this quad and this pair also. Similarly, here also there is a quad, and then this isolated one can be overlapped to form a pair. Right, now there is one isolated one here, so you can see here this symbol. Right, so when there is an isolated one, and if it is possible that at the corners of the K-map, if the mean terms are placed here, so what you can do is that using map rolling, which I've explained in the previous videos, alright, using map rolling you can combine the corners of all the four corners of one to form a quad. Right, this one, this one, this one, and this one to form a quad. So that way you will have three quads and you will have two pairs. Right, so here what we do is at first we reduce the Boolean expression for the quad pairing, and so the first quad is A complement B complement C complement D complement, that is this. Alright, since all are 0, so we complement them again. A complement B complement C complement and D. Alright, then A complement B, C complement, D complement, that is written here. Okay, and then A complement B for this cell, and then C complement D. Now in quad, B and D changes the the input values, so we have A complement, C complement. In the second quad, here you can see that C and D complement remains the same for all the four cells, but A and B changes from 0 to 1, 0 to 1. Alright, so A and C gets eliminated, the remaining is B complement, D complement. Now in the third in the second quad we get C and D complement. Okay, and in the third quad, that is the isolated one. Okay, here you see that A complement, B complement, C complement, D complement. All right, for this one, and here A complement, B complement, C, D complement, that is this. Okay, then A, B complement, C complement, D complement, so this, and then A, B complement, C, D complement for this one. So from there, A and C changes its value, B complement and D complement remains the same. Finally, we move on to the pair. In pair, C and C complement D remains the same for these two cells, but A changes from 0 to 1. So B, C, D, B, C complement and D, we get the output. Then similarly here, A and B, A, B complement remains the same for these two cells. C also remains the same. D changes to D complement, so D is removed. So we get A, B complement and C. Finally, what we do is that we OR all these mean terms and get this reduced SOP form. Right. So likewise, practice on the remaining K-maps that are given. Right, and make sure that the orientations, practice on both the orientations, all of the K-maps in the solved exercises. Okay, in the next video I'll be discussing about the logic gates and the circuits based on that. All right.